Hello guys and welcome to Battlefield 4 running on 2 Titan RTX and SLI stock through NVLiNK bridge on Intel 9 generation i9 9900K CPU overclocked to 5.3 GHz, running stable and cool on each core. I disabled 2 cores and I disabled the hyper threading technology to be able to run it stable at 5.3 GHz per 6 cores, 6 threads, and cool and stable. Okay, the voltage on the V core will be 1.41 volts. So pretty much from Core i9 9900K I emulated to Core i5 9600K because in PC gaming we don't need more than 6 cores, 6 threads in above 4K resolution in 2018, and I believe this is going to be the rule all the way till 2025. Maybe maximum we'll need the 8 threads in above 4K resolution, but that will be it. I'm about to show you, let me real quick go ahead and show you the options. Here we go guys, 7680 by 4320 pixels. Don't worry about the hertz of my display. The FPS will be the same on any hertz of the display because the FPS today is unlocked, so we're going to see the maximum possible FPS, and then you can envision what kind of display 8K resolution you're looking to buy for the 2 Titan RTX. Let's say in 2020 when you're going to buy 2 Titan RTX on the eBay used like new for $500 per video card, it's going to be a great buy guys in 2022 used like new. So pretty much ultra preset all the way with 4 times MSA, 7680 pixels by 4320 pixels, 16 divided by 9 aspect ratio, 8K resolution. Guys, keep in mind that I'm also going to show you 10K resolution, 12K resolution, and maybe 16K resolution if we're not going to overload our VRAM. This is going to be my first time in Battlefield 4 using the 2 Titan RTXs during GPU architecture, guys. And today we're going to talk about the RTX 2080 Ti versus Titan RTX, and then 2 RTX 2080 Ti video cards versus 2 Titan RTXs video cards, and I will explain to you the difference because I experienced 2 RTX 2080 Ti EVGA XC Ultra video cards, triple fan design, 2 of them in SLI, and I also experienced 2 Titan RTXs in SLI already, video cards in all kind of different games, and I was the first YouTuber that showed you guys 16K resolution gameplays of classic and all the popular games since 4 Titan X Maxwell GPU architecture. When I had the Optimus 8K resolution 60 FPS recorder, I used that as basically to capture to render and to capture the 8K resolution screen, and I showed you the 16K DSR to 8K resolution native, and in heavily I showed you a lot of games in 16K resolution, popular and classic games in 2019 on a 2 Titan RTXs in SLI, because about 30% of the classic games 2 RTX 2080 Ti is capable to run 16K resolution. I would say 30-40%, but Titan RTX can run about 99% of the games, especially the games that was released before 2018 and in 16K resolution. Okay, at the left top corner, as you can see, I have the tougher display information system updated every second. Why I call it tougher? Because it's self-explanatory. T stands for the temperature, U stands for the usage or utilization of the component, F stands for the frequency of the component, FR stands for the fan rotation, but it's only available for GPU 1 and GPU 2, which is video card 1 and video card 2 of each Titan RTXs, dual fan design, fan rotation set at 100%. My CPU today is overclocked, and I'm using the all-in-one water cooling setup by Corsair H150i Pro, which one of the best $159 investment ever in the CPU cooler, guys, especially if you're looking to overclock your CPU. As well as I'm using liquid metal thermal compound paste by Thermal Grizzly. Please keep that in mind. So we got, guys, almost full server of 64 people playing online, as you can see, and yeah, we're rocking over here. I'm not going to edit this video, I'm just going to play it the way it is. It's one take, guys, at 8K resolution. I'm also going to show you 4K resolution, 5K resolution, 7K resolution, so we can test it and compare it with 2 GTX 1080 Ti and SLI that I was running, with 2 RTX 2080 Ti and SLI, and 10K resolution and 12K resolution, which wasn't possible with the RTX 2080 Ti and SLI or GTX 1080 Ti and SLI, and hopefully 16K resolution for the first time. I showed you guys 10K resolution on 4 Titan X Maxwell GPU architectures, and each Titan X Maxwell GPU architecture was equipped with the 12 GB of VRAM frame buffer, but today each Titan RTX is equipped with 24 GB of VRAM frame buffer, so I don't see it's going to be complications to run 16K resolution, but we're going to find out. So at the left top, self-explanatory, guys. As you can see, percentage rate is our utilization for CPU and GPU, and VRAM utilization or usage is scaled in megabytes, and system RAM is scaled in megabytes as well. Right now my VRAM usage is 16,872 megabytes, and the system RAM usage is 13,661 megabytes. So I'm not wondering now why I was crashing with 2 RTX 2080 Ti in BF4 running 8K resolution without the MSAA, without any anti-aliasing, because with the 4 times MSAA 8K resolution, as you can see at Ultra, I am utilizing right now almost 17,000 megabytes or 17 gigabytes of my VRAM. I'm pretty sure that my VRAM today is healthy. I'm not offloading any data from the VRAM into the system RAM, so everything utilized and everything is used the way it should be at 8K resolution. So pretty much you'll receive the similar performance, plus minus 2-3 FPS if you're going to play it on your 8K native screen. Today I'm recording with the ShadowPlay, guys, so please add 3 FPS to the FPS counter to get the FPS without the ShadowPlay recording, because ShadowPlay is Nvidia technology and it's kind of software that utilizing your hardware resources such as GPU, a little bit of course, and a little bit of VRAM, just a little bit, but still utilizing, and the things got its only taxing 3 FPS. The ShadowPlay recording software, guys, is one of the best. It's not one of the best, it is the best that is available in 2019 and before 2019 on the desktop screen recording and gameplay screen recording industries, guys, and it's available for you for free if you're owning the GTX or RTX video cards, or Titan RTXs as well, any Nvidia products such as video card. Look at that FPS, above 70 FPS average. Wow. Latency delay below 20 milliseconds, so pretty much this is a comfortable gameplay. Here's the formula, guys, that I'm applying to find out if the gameplay is comfortable or not. If you having below 5 milliseconds latency delay before each frame is rendered, the gameplay will be amazingly comfortable. If you have below 10 milliseconds latency delay, the gameplay will be very comfortable. If you have below 20 milliseconds latency delay, the gameplay will be comfortable. If you have below 30 milliseconds latency delay, the gameplay will be playable. If you have above 40 milliseconds latency delay, the gameplay will be benchable, testable, but not playable status and not comfortable status. Hopefully this makes sense. So single RTX 2080 Ti video card, guys, versus the Titan RTX. Titan RTX has advantage of 256 CUDA cores in terms of the PC gaming. It has a little bit more of the tensor cores, but it doesn't matter in terms of the PC gaming and in terms of the Battlefield 4 that is not utilizing the tensor cores. So pretty much we're utilizing today the CUDA cores and VRAM out of our video card. Today I'm running 2 Titan RTXs and SLI. So single Titan RTX, guys, has advantage 256 CUDA cores. However, it's not enough when Titan RTX running at stock frequencies to outperform RTX 2080 Ti video card running maximum overclock on air, which is above 2000 MHz on the GPU and above 15,000 MHz on the VRAM. The stock VRAM frequency for the Titan RTX or RTX 2080 Ti will be the same, will be 14,000 MHz. It's the same RAM, by the way, as well, GDDR6 Samsung. So in terms of the VRAM overclock, both video cards going the same, up to 16,000 MHz or 16 GHz per VRAM, so additional 2,000 gigahertz overclock, and it's kind of stable and it's kind of beautiful. As you can see, guys, it's a full server right now, 32 people versus 32 people playing online in this Battlefield 4 PC game. FPS is above 60 FPS average, latency delay is below 20 milliseconds average, so pretty much it's comfortable. Sometimes, as you can see, it's dropping throughout the volumetric particles and very long life cycle of those particles per second. It's dropping up to, I just saw the minimum was like 45 FPS, but it's staying mostly above 50 FPS average. As you can see, I would say 58-64 FPS average. And just because I'm recording with the ShadowPlay, you gotta add 3 FPS to the FPS counter. So whatever you see right now, add 3 FPS and you will receive the real FPS output without the ShadowPlay recording. Guys, today I'm coming in real time. I'm not reading this information, I'm just commenting the way we're watching it together. And I was PC gamer, PC hardware enthusiast, PC overclocker since 1998, so I have over 21 years of experience. And I am software developer, web developer, graphics designer, 3D artist, and hardware engineer with experience of over 10 years. Keep that in mind. So pretty much I have a lot of experience and tips with you guys to share. Plus, I was the first YouTuber that uploaded videos in 16K resolution of gameplay to YouTube, guys, for you to watch. Since 4 Titan X Maxwell GPU architecture, the first game was Half-Life 2 back in the May of 2016. As again, I was having the Atomos 8K resolution 60 FPS recording device that I used as 8K resolution native screen, and I was outputting to that device. Go ahead and check out the iplay4k.com or iplay16k.com YouTube channel for great 16K resolution videos on 4 Titan X Maxwell GPU architecture, 2 GTX 1080 Ti videos, Pascal GPU architecture, 2 RTX 2080 Ti's, Turing GPU architecture, and 2 Titan RTXs and SLI, guys. Excellent guys. Scalability, as you can see, above 95% per GPU1 and GPU2 almost constantly on average. So pretty much I would say we are about 1.92 times faster than a single Titan RTX. So guys, 256 CUDA cores advantage of the Titan RTX versus single RTX 2080 Ti. Okay, so this advantage can be equaled, or even RTX 2080 Ti can be faster when you're going to maximum overclock your GPU and VRAM, which is the GPU overclock above 2000 MHz and VRAM above 15,000 MHz. And at this condition, you will be equal as Titan RTX running at stock, or even faster than Titan RTX running at stock. However, when 2 Titan RTX's video cards and SLI, that advantage of 256 CUDA cores is doubled, and we have 512 CUDA cores advantage versus on 2 Titan RTXs and SLI versus 2 RTX 2080 Ti. And in this type of scenarios, 2 RTX 2080 Ti, even with maximum overclock on air, such as above 2000 MHz and even 2.1 GHz or 2100 MHz on the GPU, synchronized on each RTX 2080 Ti and 16,000 MHz on our VRAM, cannot be equal or faster than 2 Titans RTXs and SLI, guys, because as again 512 CUDA core advantage, guys. And on top, when 2 Titan RTXs will be overclocked, we increasing that winning performance on the 2 Titan RTXs even to the higher FPS. Keep that in mind. So pretty much take it like this: 1% of the Titan RTX let's say right now I'm utilizing 98%, right, on the GPU 2. So we're losing 2% in our CUDA cores in terms of the utilization. So 98% CUDA cores utilized and 2% is not utilized. So what does that mean? It means that 1% of a loss throughout our GPU utilization will be equal to 47 CUDA cores. Why it is? Because Titan RTX has 4,608 CUDA cores, and to be exact, 1% will be 46 CUDA cores, 0.08. But we cannot do that, so it's 47 CUDA cores to be exact. Okay, so 2%, let's say we're utilizing 98% right now, is, by the way, very good SLI utilization. When SLI utilization above 97% per GPU1 and GPU2, I call it very good SLI utilization, and when it is 99-100%, I call it excellent, amazing SLI utilization or SLI scalability. But it's supposed to be for both GPUs. So when right now 2%, it was 98, right? We're losing 2%. We're not utilizing 2% of our CUDA cores on our GPU. So 47 times 2, guys, and it's going to be 94. So we just lost the 94 CUDA core advantage. So whatever your 2 Titan RTXs is not utilizing at 99-100% per GPU1 and GPU2 and SLI, 2 RTX 2080 Ti, guys, video cards and SLI can take advantage with the higher overclock if your Titan RTXs, 2 Titan RTXs running at stock. Keep that in mind. They can be equal in these scenarios, and they can even be faster, slightly faster, especially when your utilization like 92% per GPU1 and GPU2 under the Titan RTXs. Similar utilization under the RTX 2080 Ti will give them another advantage to the higher GPU frequency, because RTX 2080 Ti during GPU architecture video card can be overclocked to a higher GPU frequency versus the Titan RTX. Titan RTX, you cannot push Titan RTX above 2000 megahertz on the GPU. It's just going to freeze and crash on air, of course. Maybe on the liquid nitrogen too, or liquid ice, or custom water cooling loop, maybe you can push to 2.1 gigahertz. But keep in mind, I'm talking about the scenarios, both video cards on air and maximum overclock. Okay, so RTX 2080 Ti, when your GPU utilization 92% under your 2 Titan RTXs, so 2 RTX 2080 Ti will take advantage due to higher maximum on air overclock on GPU, and of course you gotta overclock your VRAM to be able to take that advantage. And because 2 Titan RTXs will lose 8% of the CUDA cores, so 8 times 47, so it's going to be almost 300, above 300, was 350, 370 CUDA cores lost. So the advantage out of 512 CUDA cores is not going to be that big, and this is where the 2 RTX 2080 Ti will take a lead. Hopefully, guys, this makes sense. I explained to you everything. At the same time, I hope that you are looking at the left top. Let me real quick go ahead and show it to you. You're gonna look right here at the VRAM usage, which is right now 16,890 megabytes. The system RAM usage, which is right now 13,528 megabytes. And then GPU utilization 98% right here, and then the CPU utilization, which is below 60%. And today I'm running 6 cores, 6 threads. I disabled 2 cores, and I disabled the hyper threading technology to eliminate any logical cores, because I believe the logical cores bring to us the latency delay, increasing our latency delay, because physical cores is 1.5 times faster than the logical cores, and logical cores comes through the hyper threading technology on Intel CPUs. Hopefully this makes sense. 5.3 gigahertz per core our overclock frequency was, or 5300 megahertz, and here's the every single core utilization for you. 100% fan rotation is again. Let me real quick, guys, and lower it from ultra. I'm going to keep going on ultra, but I'm going to switch to custom, and I'm going to just disable the anti-aliasing completely off. Let's go ahead and now look how we're going to improve in terms of the performance, in terms of the GPU utilization, GPU1 and GPU2, and in terms of the CPU utilization, and in terms of the VRAM usage and system RAM usage at the left top. Look at that, immediately improve in terms of the FPS. 85, 92 FPS. Wow, this is, guys, 8K resolution, ultra, without the anti-aliasing, and you don't need the anti-aliasing at 8K native screen, guys. It's going to be everything going to look so perfect, unless your screen above 120 inches, and you know, that screen is going to cost you a fortune even in 2022. Guys, if you're watching this video in 2022 and you cannot play 8K resolution yet, go ahead and smash that like button, and don't forget to check out 10K resolution on the same computer, 12K resolution on the same computer, and hopefully 16K resolution if we're not going to overload our VRAM. But already at 8K resolution we're using about 14,000 megabytes of our VRAM, so almost 15 gigabytes of the VRAM usage right now at 8K resolution. So look like Titan RTX doesn't want to actually compress a lot of data, or maybe this is the right utilization of the VRAM. And when I was testing for Titan X Maxwell GPU architecture in 8K resolution, maybe during that time we were offloading some data. During that time I didn't know that Nvidia driver is having the capability to offloading some data from the VRAM and storing the data into the system RAM. If the Nvidia driver deciding that, look, it's going to be VRAM overload, and if you don't want to crash the game, we gotta go ahead and do it, but we're going to slow down the game in terms of we're going to lose a lot of FPS because we're going to offload the data from the VRAM into the system RAM, and we're going to increase in our latency delay. And 8K resolution on 4 Titan X Maxwell GPU architecture, we are seeing a big, very like increase in latency delay performance, and it wasn't good. It was like above 30 milliseconds latency delay, and right now we're below 20 milliseconds on average latency delay. So there is a possibility that I was running 4 Titan X Maxwell GPU architecture in 8K resolution. I probably was offloading a lot of data from the VRAM into the system RAM. And let's go ahead and revisit that video, and let's go ahead and check out the system RAM usage on that video, because as again, during that time I didn't know that we can offload the data to avoid the game crash, and we can offload the data and load it into the system RAM. But as again, my system RAM today is clocked 2133 megahertz, 2133 megahertz CL13 DDR4, cheapest possible DDR4, because I do not believe, as again, in DDR4 frequency value when the game in PC gaming, when the resolution set at 4K resolution and above. Guys, it's running so comfortable right now, below 20 milliseconds. FPS, even with the volumetric particles, as you just saw, was still above 70 FPS average. This is amazing. But mostly we're staying above 80 FPS average and below 15 milliseconds latency delay. So there is a possibility we are offloading some data, and that's why even if MSI Afterburner not showing you that you kind of up to 12,000 gigabytes on your VRAM, it can show you that you're around 11,000 megabytes, and the extra 1,000 or 2,000 gigabytes it was storing into VRAM. And in our case it was storing exactly 2,000 megabytes into our VRAM for sure, as minimum. So yeah, and it's hard to see. Now we know, guys, and I came up with this idea only after the testing RTX 2080 Ti, when I find out, when I was testing 16K resolution, because I compared that versus the Titan XPs and Titan X Maxwells, and then I saw, wait a second, there is something going on at the games like Half-Life 2 that I showed you guys 16K resolution, and other games. I'm like, okay, like Counter-Strike Go, let's say. Counter-Strike Go is using a lot of VRAM, and I recorded the CSGO, guys, 16K resolution first time in May, I believe, of 2019 on 2 RTX 2080 Ti video cards in 11 gigabytes. So 11 gigabyte was good to go in Counter-Strike Go. But as again, we gotta retest it, revisit that test with the Titan RTXs. And just because the Titan RTXs, we have unlocked abilities all the way to 24,000 megabytes of the VRAM, we can see exactly how much VRAM is utilized. And as you can see, at 8K resolution, we have almost 15,000 megabytes VRAM utilization. So pretty much we are offloading almost 3 gigabytes of VRAM data into the system RAM when I was running 4 Titan X Maxwells or 2 Titan XPs or 2 GTX 1080 Ti's or 2 RTX 2080 Ti's in SLI. Keep that in mind. But 2 RTX 2080 Ti guys in SLI is crashing a lot in Battlefield 4 in 8K resolution. It's almost unrunnable. Keep that in mind. If you will achieve to load the level, succeed to load the level, you will probably crash it in about 5-7 minutes, especially during the heavy particles, volumetric particles, especially on this level, because this level kind of has open scenery and you can see those volumetric particles from a distance, and as you can see they have a very long life cycle per second, a lot of particles coming out. Okay guys, self-explanatory. You saw the data at the left top. FPS 8K resolution at ultra without the anti-aliasing above 70 FPS average. I would say 78-82 FPS average with the 4 times MSA, everything at ultra. We are receiving like 70 FPS average, 65-70 FPS average, but sometimes it was dropping to 48 FPS during the heavy volumetric particles. Okay, pretty much I explained to you guys everything. It was the multiplayer game, PC game, 64 players was playing, and let me real quick go and show you my computer components, a little bit more details about them, and we're going to go ahead and wrap it up, guys. Okay, trying to close the game, but let me go ahead and close it by myself, I guess. Take some time to close it, come on. Okay, so while it's closing the game, as you can see guys, Titan RTX was used today. As I told you, it has 4608 CUDA cores, okay, and this was utilized during our gameplay. The VRAM is also very important to consider when you're going to play 8K resolution and above. 24 GB of VRAM. I believe Nvidia secretly tested Titan RTX or T-Rexes, like Jensen Huang, Nvidia CEO, in 2018, saying, and by the way, I'm a big fan of Jensen Huang, saying, and they decided to go ahead and equip 24 GB on the Titan RTX, and now I understand why they did it after testing this 2 Titan RTX in 16K resolution, because 2 of them is capable with 24 GB of VRAM to run a lot of games at 16K resolution. Let's say Titan RTX 2080 Ti, 2 video cards in SLI, is capable to run about 40-60% of the games, most of them classic at 16K resolution, when Titan RTX is capable to run about 90% of the games ever on PC games at 16K resolution. Keep that in mind. Of course, I'm not saying the FPS will be very comfortable or even under the playable status, but at least it's going to be under the benchable status, under the testable status. So guys, you saw the utilization, everything under the 6 core 6 threads. Here is my CPU Z. As you can see, I was running 5300 MHz on my CPU overclock per core, 6 core 6 threads, disabled 2 cores and hyper threading technology, and in a second I will explain to you why. I was also running 50 multiplier for my AVX instructions, so pretty much 5000 MHz or 5 GHz for our AVX frequency and 5300 MHz for our external frequency or total CPU frequency, 5.3 GHz. Okay, I was using the cheapest possible ROG Maximus 11 here Wi-Fi model motherboard. I'm not advising you this motherboard unless you are professional. This motherboard has a lot of problems, and you know, if you're looking to get the best Z390 or Z370, I also not advising you to get Maximus 10 here Wi-Fi. They kind of the same, and they kind of trouble motherboards. So you gotta be ready for a lot of troubleshooting if you're trying to get this motherboard, and you gotta be experienced and professional overclocker and PC hardware enthusiast. So cheapest possible DDR4 memory is again 10,066 times 2 will be 2,133 megahertz, and CL13 aggressive timing. Guys, keep in mind when this system RAM is running 2,133 megahertz with the much aggressive timing CL11, and it's easy to set in the BIOS and it's stable. I'm similar in terms of the performance in 3D Mark test Ultra version 1.1. At you know, just default test, I'm about 28 points higher with the DDR4 2133 MHz with the CL11 timing versus the 4000 MHz on the same system, same video cards, 4000 MHz DDR4 CL18. I'm even faster. So it's not only about the frequencies, especially when we're talking 4K resolution and above. The latency delay of the CL and the DDR4, the biggest reason what you want to count when you're playing games above 4K resolution. And as you can see, for free, I overclock it through my BIOS CL11. I force it to CL11 instead of CL13. I saved about $400 because 4000 megahertz CL18 32 gigabyte DDR4 costs about $400 bucks, and I saved that money. And 32 gigabyte DDR4 2133 megahertz CL13 core 7 gens that I'm having today pretty much cost $128. Saved at least $300 guys. Okay, and here we go for the naysayers to Titans. Of course, GDDR6 Samsung 24 gigabyte, beautiful TU102 GPU, revision 300 A1, and benches. So here's guys why I shut down two disabled two cores, two physical cores, and I disabled the hyper threading technology so I can run stable 5.3 gigahertz per core, nice, cool and stable with the voltage 1.41 volt. And let me show it to you. Let me switch to a default 8 core 16 threads i9 9900K without the disabled cores and without the disabled hyper threading technology. As you can see, I'm dominating it in about 45 points in terms of the single thread, single core performance. And this is, guys, a lot. And so pretty much I'm going to dominate then 2 cores, 3 cores, 4 cores when it's equal to. And as you saw in Battlefield 4, we don't need more than 6 cores. We are good to go. We wasn't even utilizing 90% of our CPU. And guys, there is a signal when you need to upgrade to 2 more cores on the CPU when your CPU in the games utilize above 92%. This is a clear signal. Look, you gotta go ahead and buy yourself a better CPU and add 2 more cores, because the Nvidia driver can decide to go ahead and kind of do some manipulation with the data throughout the gameplay of PC games, and you can lose the FPS and during this manipulation by the driver and operating system. So the game is not going to crash, it's not going to overload your CPU with a lot of instructions, and with 2 more cores completely makes sense. Otherwise 8 cores doesn't make no sense, guys. But I believe in 2025 all what you will need to have for PC gaming will be 8 threads CPU, and that's it, but at the highest possible frequency as possible in terms of the PC gaming, of course. Okay, so you can test this, and it's not required for you to have the Titans. This is the CPU test, and we're looking at the single thread performance. And as you can see, I'm only 6 threads, and this kind of purplish line is 16 threads. So 3 times more threads, but it's not 3 times more in performance. So those logical cores, as I told you guys, 1.5 times slower than the physical cores. So whatever you play in games, you want to disable the logical cores to pretty much to increase the latency delay, to compute the instructions only on the physical cores of the CPU, because they're 1.5 times faster than the logical cores that came with the HT technology, hyper-threading technology. Hopefully, guys, this makes sense. This is all the experience I got throughout all my tests, and I was testing a lot. Especially, I was extensively testing since 2016-2018. Go ahead and check out iPlay 4K YouTube channel, iPlay 16K YouTube channel. Before I will let you go, one more thing. Here's my DDR4 benchmark at 2133 megahertz with the CL13, and this is the CPU benchmark clock at 5.3 gigahertz, level 1 cache, level 2 cache, level 3 cache. Yeah, guys, and this is my picture with Titans. Thank you so much for watching. Don't forget to visit iPlay4K.com or iPlay16K.com. smash that like button for the support and motivation for me to create more great videos. Check out the 16K resolution, 12K resolution, 10K resolution on this system. This is amazing. If you have 8K native screen, you better DSR it to 10K or 12K for much better visuals, guys. You're going to enjoy and you're going to see the future at the same time, and you're going to utilize almost all your CUDA cores, and this is the goal if you purchase 2 Titan RTXs. But for 4K resolution, I do not advise you even to purchase single Titan RTX. Buy 2 RTX 2080 Ti if you have money for single Titan RTX. Do not buy 2 Titan RTXs for 4K resolution gaming at all. And if you don't have money even for 2 RTX 2080 Ti's, if you're playing 4K resolution, then buy just 1 RTX 2080 Ti. You will be good to go. You will be Gucci. But you only need 2 Titan RTXs, guys, in SLI when you're playing 8K resolution and you want to have that comfortable 8K resolution game frame rate per second or above 8K resolution. Then this is the scenarios, and as you can see, I was showing a lot of 16K resolution gameplays. This is the scenario for me when I need to have 2 Titan RTX because in SLI, because RTX 2080 Ti going to crash, because 11 GB of VRAM on RTX 2080 Ti of two of those video cards still not going to be enough to play games above 8K resolution, newer games comfortably, or like I told you, only 60% of games will be runnable at 16K resolution. Most of them will be classic, but on Titan RTX 99% of the games you can run at 16K resolution as benchable, testable conditions. Okay guys, right now I'm putting some great videos for you to see. If you didn't see those videos, go ahead and check the video description, smash that like button, subscribe, smash that bell, share it with the friends, guys, positive comments, and I will see you till the next time.